So we're going to talk about solving equations, which hopefully will be like a breath of fresh air coming out of geometry, right? This is what you're familiar with, but we have to talk about the properties of quality before we ever talk about solving equations. These properties apply all the way across the board. Some of them are intuitive, reflexive, A equals A. This doesn't seem like you would need to know this, but if you are subtracting something from both sides, it has to be equal. And so if you know that 3 equals 3, then you know that you will not affect an equation if you subtract it. They give the example, 2x minus 7 equals 2x minus 7. All right? Which if you were to solve this, that would mean every x would equal every x, by the way, because the whole equation is equal. The next property is symmetric. You can flip your equal, meaning you can take your two sides of the equations and flip-flop them. This helps sometimes when you are solving and you always want your variables on one side of the equation, right? And so it's just a property that we're going to use probably unknowingly, but that you can take the equation and you can just flip it and it's still the same, right? And so if you were to think of it as weights and you have two things that weigh exactly the same, if you were to flip them on both sides of the weights, it wouldn't change it. They would still be exactly the same weight. Transitive property. This should seem vaguely familiar because we did use this in geometry. If A equals B and B equals A, then A equals C. Transitive property, right? We used these when we did law of syllogism, things like that, when we did those type of properties. But when we did proofs, we also used transitive property. So if you have something and you know it equals something else, then it can replace anything else because of the transitive property. Addition. If you have something that is equal and you add the same thing to both sides, those two things are still equal. All right? Again, think of it as weight. If I have something that equals 5 pounds on one side, something that equals 5 pounds on the other, if I add 3 pounds to both sides, they're still going to be equal weight, right? I did not change the equality. That's all this is saying. And that includes subtraction, by the way, because subtraction is just adding the opposite. Multiplication, if you multiply an equation, both sides of the equation by the same thing, you do not change the equation. It is still equal. Now, for all of these, you have to keep in mind that is your goal. Your goal is to maintain equality, right? If you are given something that is equal, then you have to do everything to maintain that equality all the way down the process so that when you get to the bottom and all you have is an X and a number, you know that that's correct because you have maintained your equality. Meaning you can't multiply one side by positive 5 and the other by negative and expect those things to still be equal because you didn't multiply by the same thing. Or you can't subtract 5 from one side and add 5 to the other and think that you are maintaining equality, right? So whatever you do to one side, you have to do to the other. Now, I say this, but when you start solving, some of you are going to subtract 5, and then on the other side, I'm going to see a plus 5, right? And so you have to keep in mind that your goal is to maintain equality all the way down. And so after that, we are going to actually do that. So do these 3. Look at these and tell me what property allows you to have these as true statements. If 7D equals 21, then D equals 3. What can you do? Which property can you use that shows that is true? If C plus 6 equals 14, then C equals 8. What property there? And then the last one, Z plus 5 equals Y, and Y equals X minus 3, then Z plus 5 is X minus 3. So go ahead and do those 3 really quickly. Just write down those properties. Multiplication, right? So technically we use the multiplication property there. They actually multiplied by 1 over 7 if you're being technical about multiplication. All right. What about 2? What did they do to both sides here? They started with C plus 6 equals 14. How did they get to C equals 8? What did they do? They subtracted, but remember subtraction is just adding the opposite. So technically the property that you're using here is addition. Addition property of equality. If Z plus 5 equals Y and Y equals X minus 3, why can we say that Z plus 5 equals X minus 3? The transitive property. So then we're going to solve. So as you recall, your goal is to get X all by itself. And you want to do that in the easiest method possible. So when you're doing this, you could technically divide by 5 first, but I wouldn't recommend it, as you'd have to divide everything by 5. So the reason we start with our addition and subtraction is because if you start with one thing, you have to do it to every piece of it when it's talking about multiplication and division. And so your goal is to have multiplication and division actually your last step, so that you don't have to worry about all the pluses and minuses in there. All right? And so when you solve something like this, you want to start with your addition and subtraction. The one below it, you can't start with addition and subtraction because we have some parentheses in there. And so when it's something simple like example 1, you want to add or subtract first, then you want to multiply and divide. Our goal is to get the variable all by itself. And so we're going to start here, and we're going to say, well, I'm going to get rid of everything that doesn't have the x with it, which means I am going to subtract that 12. Remember, I have to get rid of it on the side that it is with the x. It is plus 12. The only way to get rid of it is to subtract 12, right? And so that's exactly what I'm going to do. I'm going to say minus 12 here. 12 minus 12 is going to zero out on this side. But my property says if I do it on the left side, I have to do it on the right side. So I am going to say minus 12 over here as well, right? And then I need to bring everything down. I need to bring down this 5x. I need to make sure that I write that equal sign. And then I need to do my actual addition subtraction. Negative 18 minus 12. This is where we're going to go back to our first couple of sections. Subtraction is adding the opposite. So basically I have negative 18 plus a negative 12. What do I have there? Negative 30. And now I have all my variables on one side, my numbers on the other, and now I can do my division. And so I'm going to divide both sides by that 5 over here. 5 divided by 5 gives me that 1x that I was trying to get. Negative 30 divided by positive 5, we're going to apply those rules. Negative divided by a positive gives me negative 6. Now the nice thing about algebra problems is I can check them, right? So I wouldn't recommend checking them as you go, because if you made a mistake, you're probably going to make the same mistake, by the way. So I recommend doing the problems and then going back and checking, because you'll find that your brain will make the same mistake over and over if you just keep doing it back to back. But when you're done with these, you can go back and you can just plug that negative 6 in. And you can see that when you plug it in, you just do order of operations at this point. Multiplication, 5 times negative 6, negative 30. Then we're going to do our addition. Negative 30 plus 12 is negative 18, and you can see that that is correct. And so that's the nice part about algebra problems. You can always check it, plug in your x. Let's look at example 2. Example 2 is a little bit more difficult because you do have some distribution that has to happen before we can start. All right? So I'm just going to move him out the way. And we're going to do this one. So with this one, we have distribution because I can't add or subtract because they're inside parentheses, right? And so the first thing I need to do here is simplify my sides. You want your sides as simple as possible before we start moving stuff around, all right? And so for this one, I am going to distribute these guys first. So I'm going to take that negative 3 and distribute, and I'm going to take that positive 4 and distribute. So I have negative 3 times x. That's just negative 3x. I have negative 3 times positive 2. Negative times a positive, negative 6. And that side is about as simple as it gets, right? I can't do anything else. Over here, 4 times x gives me 4x. 4 times 18 gives me, what, 72? 40 plus, what, 32? And then don't forget this little thing right here. This would be what most people would make a mistake on. That little minus 1 would be totally forgotten for the most part. I mean, honestly. So don't forget if it has something outside. 1, you do not distribute to it because it is outside of the parentheses. But 2, make sure you bring it down. So that's a minus 1. Now, is the right side as simple as possible? No, it is not. I have like terms. So I would want to combine these before I moved on. So the left side is as simple as it gets. The right side, I'm going to do 72 minus 1. And now those are simple. Now here's the thing. It doesn't matter which way you move things. You can move all your variables to the right side. All right. So It doesn't matter which way you move it. Variables can always, like some people always want their variables on the left-hand side because that's just how their brain works. I want my variables on my left-hand side. I personally always want my variables positive if I can manage to do so, right? And so personally, if I were doing this, I would move my variables to the right and my numbers to the left. Either way you do this, you're going to be subtracting and adding negative numbers, by the way. All right? So either way, you're going to run into the same issue. But it just depends on what you want to do as far as how you work it. As long as before you multiply or divide, all of your variables are on one side, all of your numbers are on the other. It doesn't matter which way you move it, all right? Just pay attention to your positives and negatives, all right? So if I were to move my x's over, let's say I were to say, okay, I'm going to move this 4x over. It's a positive 4x. To move it over, I have to subtract 4x. And so I would subtract 4x over here. If I do that, then I have to move my numbers to the other side, which means I would need to add this 6, right? So my goal here is that when it's all said, I have moved my variables one way and my numbers the other way, all right? If you don't do that, you're going to randomly put an equal sign somewhere and your positive negatives are going to be wrong. I've seen it happen, right? So if you move your variables one way, move your numbers the other way, and then you're just going to add down. So you'll see that I have canceled out my numbers on this side, and I just have variables. -3 and -4. Remember, it's adding the opposite. So here I have -7, right? -7. Bring down your equal sign so you remember where it is. You'll notice on this side I canceled out my variables. And I have 71 plus 6. This is my goal. Variables on one side, numbers on the other. And now that I have it, it's a pretty simple step. What do? I'm going to divide by -7. So on the left, those -7s cancel. On the right, I have positive 77 divided by -7. What does that give me? -11. And I can check it, right? Now remember, if you check it, that -11 has to go into every place that you had a variable. So if you check this guy, you have to plug in the -11 here and the -11 here, all right? And then do order of operations. The question here is, why wouldn't we subtract this, right? Think about what you're doing. The only time you do the opposite is when it's moving across that equal sign. And this is one of the most common mistakes, so I'm glad you asked. When they're on the same side, just do whatever it says. So this is a plus 4 and a 12x on the same side of the equation. You just add them. But you'll notice that when I moved across the equal sign, this was a positive 18, then I changed the sign and moved it over. So the only time you're going to switch what the sign actually says in front of it is if it's crossing that equal sign and you're adding or subtracting them, right? And so like, for example, here, when I combined these two, 12 and negative 18, I kept that as a negative 18 and it was a negative 6, right? But when I moved to the negative 6 across the equal sign, you'll notice I used a positive 6, right? Because I'm actually transferring it by addition or subtraction to the other side. So if it's on the same side and you're combining terms, do whatever it says. If you're moving it across to combine it with something, then you're going to change the sign. So anytime I look at something that has fractions and decimals, I try to get rid of them. As much as I love fractions, I don't really want to solve an equation while it has fractions in it necessarily, if there is a way to get rid of the fraction. All right. So the first shortcut I'm going to show you deals with fractions specifically. If I have fractions in my original problem, I can multiply every single part of the fraction by the common denominator and it will get rid of all of my fractions. It doesn't mean my answer won't be a fraction, but it does mean I won't have to deal with fractions all the way down my solving. All right? Because think about what this would mean. This would mean adding and subtracting common denominators, multiplying and dividing, potentially keep, change, flip, which is fine, except that if there's a way to do it easier, I lower my risk of errors pretty much. And so the first thing I'm going to do here is I'm going to look at my denominators. My denominators are 4, 3, and 6. 4, 3, and 6. And I'm going to say, what is my common denominator between 4, 3, and 6? Well, 6 is my highest number. 4 does not go into it. So I can't use that. I'm going to double it, 12. Do 4, 3, and 6 all go into 12? Yes, they do. That's my common denominator. And so I'm not going to get that common denominator. I am going to multiply every single piece by that common denominator. So I am going to take the x over 4 and I am going to multiply that by 12. I'm going to take the x minus 1 over 3 and I'm going to multiply that by 12. And I am going to take the x plus 3 over 6, and I am going to multiply that by 12. Why does this help me? Well, they're all going to cancel, right? It's 12 over 1. Remember, when you're multiplying fractions, you can cross cancel, right? And so if I look at this first one, 4 goes into 12. By the way, they're all going to go into 12. That's how I found 12. It was a common denominator, which is a common multiple. So 4 goes into 12. It's going to cancel out there, and it's going to become a 3 here. 3 goes into 12. It's going to cancel out here. It's going to become a 4 there. 6 goes into 12. It's going to cancel out here and become a 2 there. So now I have no denominators. I just have 3 times x plus 4 times x minus 1 equals 2 times x minus 3. Most of you would probably have that problem instead of the original, right? Because you know what to do with that. The original, you're going to be multiplying by denominators, subtracting fractions, etc. All right? So now I'm just going to simplify this. 3 times x. Well, that is just 3x. Here I'm going to distribute. 4 times x. 4 times negative 1. On the other side, distribute. 2 times x. 2 times negative 3. Right? And now I have a much simpler problem. Can I simplify the left side? Yes, I have this, 3x and 4x. Then I'm going to do what I've done before, move my variables to one side. Move my numbers to the other side. I have 7x minus 2x. What does that give me? 5x. 5x. I have... When I moved this down, what did I do wrong? What did I do here when I moved this down? Yeah, this should be a plus. This should be a plus. That should be a plus. There we go. 6 plus 4 gives me 10. All right, and then we're going to divide. So what is my x here?
2.
2. Much easier than if I had dealt with fractions the whole way down, right? Adding and subtracting fractions would have been a pain here. So fractions are the first one. Fractions are something we usually try to avoid because there's a lot of room for error when you're adding and subtracting fractions, right? The other area that we sometimes run into problems are decimals, all right? And so when I look at decimals, I think I want to get rid of decimals as well. And the way you get decimals is you just look and see what's my highest number of decimals that any one of these has. And so I'm going to look and I'm say, well, this guy has 2 decimals. This one has 1. This one has 2. And so when it's like this, you don't have to worry about the inside right now, just the outside ones. You can say, I can move everything over the highest number of decimals. The reason I can do that is I'm technically multiplying everything by 100, all right? But what you do is you take your highest number of decimals and you move everything over that number of decimals. So I'm going to take this 0.05 and I'm going to move it over 2 places, and that's just a 5 in. I'm going to take this 0.01 and I'm going to move it over 2 places. I have an extra place. What do I do with him? Put a 0, so that 0.1 becomes 10. And same thing here, 2 places, that 1.65 becomes 165. Again, would you rather? Would you rather solve the top one or the bottom one?
Bottom.
Yeah, most people would rather solve that bottom one, right? And so now I'm just going to do what I would do. The 5n doesn't simplify. We have 10 times 20. That's 200. 10 times negative n, negative 10n equals 165. Combine my like terms, 5 and negative 10. They're on the same side of the equation, right? So here I'm going to just keep them the same. 5 plus negative 10 gives me a negative 5n plus 200 equals 165. I'm going to move that 200 over because my variables are already by themselves. Negative 5n equals negative 35. What's my final step here? Divide by what? Negative 5. So I end up with n equals negative divided by a negative gives me a positive 7. Much, much easier to solve when you get rid of those decimals. All right? Are constantly solving for the same variable. This will happen in like chemistry, physics. You have your original problem and you have a variable that's over here with all these variables, and that's the guy you're solving for. And so every time you do the equation, you have to back into the answer. And so literal equations help you rearrange it so that what you're solving for is already by itself before you start plugging stuff in. All right. And so they gave the example of the equation they used to test or analyze bridges and the temperature effects on the rods. And if they're constantly solving for one of these, like the change in temperature, what they're going to do is they're going to move all the variables over so that the change in temperature is what's always by itself, so that they're not constantly solving back into it. Having the literal equation arranged the way you need it very often helps reduce your errors. And so the example they give us is 7x plus 18b equals 5b minus ax, and they want us to solve for x. All right? So you have to think of this as an equation with just all these instead of numbers. You're going to do exactly what you would do. You would move all your x's to one side and everything that doesn't have an x to the other side. And so you're going to take this and you're going to say, well, I have 7x plus 18b equals 5b minus ax. And so I need to move my x's to one side. Well, I have this x over here, and I really need it to be on the other side. It's a minus ax. How do I move it to the other side?
You just subtract the x. Well, not subtract, divide the x part.
We want to move the whole entire group. So we're going to take this whole group, and since it's minus, we're actually going to add the whole group. And we're going to do this. Now, this seems counterintuitive because it doesn't actually combine. It cancels out here, but over here we have 7x plus ax plus 18b. So we have successfully moved my x over. What's the problem on the left side? I have something that doesn't have an x in there, right? And we're going to apply that same method that we actually did. Just like we moved the x over, we're going to move the 18b over. So we're going to take that 18b, it is a positive, and we are going to subtract it. All right? Now it cancels out here, and we have this right here. 5b minus 18b, we can combine those. Right? Same variable, like terms. We just subtract them. What's 5 minus 18? It's negative 13, right? But we still have a problem. Is x by itself? Did we solve this equation for x? We did not. So when you have something like this, the only way to get the x by itself is to undistribute, right? Give me 1 second. Factor it out. We'll finish these tomorrow. And then you can divide by that group. So here's what I'm going to do. I'm going to give you your homework. So for homework, you do not need to worry about 17 and 19 because those are the literal equations. We'll finish those tomorrow. So just do your 1, 5, 9, 13, 25, and 31. You do not need to worry about 19 and 17. Those are your literal equations. We'll finish those tomorrow.